my focus with this presentation is on the European standards dealing with odors. There are mainly two published standards. The second one is divided into two parts. A third standard about instrumental odor monitoring is in progress. And I also will do some consideration about the other methods that in some way are or can be standardized at EU or CEN level. The first one is obviously dynamic olfactometry. The title of the standard is that one. The first edition is of the year 2003. The standard is now under revision by the Working Group 2 of the same technical committee. The technical committee that is involved is the committee about air quality. So we are dealing with the odor in this field, not about I don't know odor for in the aroma field, but the final aim of the standard is say something that is important for environmental problems. So about annoyance and nuisance. Yes, the technical committee 264 is the competent committee for many other measurement methods. For example, dealing with emission to air, atmospheric pollutants in ambient air, deposition of pollutants, and so on. I say this because the structure of the standard and the requirements above the standards are those that are shared with the other standards about air quality. So there is a framework behind this standard. In fact, the structure of the standard is not conceptually different from that of standards dealing with nitrogen oxides, for example. So there are clauses about calibration, repeatability, reproducibility, accuracy requirement on the equipments, the test report, and so on. The dynamic olfactometry method is a method for determining the odor concentration of a gas sample by sensory analysis. This is the strange aspect of this standard with regard to the other standard of the same technical committee, because it is the only standard that has this peculiarity. In fact, sensors are human assessors. The meter is the human olfaction. Since among people there are enormous differences, as Laura said, also in the literature, the odor thresholds of odorant are reported so different, because in fact odor threshold of different people are very different each other. So the main aim of the standard is enhancing the objectivity of the results by defining a standard sensitivity to one particular odorant. That is this particular odorant is N-butanol, and in the standard defines the conventional odor detection threshold of N-butanol in nitrogen. So this solution has the result that a lab can buy a certified standard reference standard of N-butanol in nitrogen, so I can calibrate my measuring system by a certified reference standard, reference material. This threshold is defined with the value of 123 microgram of N-butanol in 1 cubic meter of nitrogen, that is 40 ppb. This mixture has the conventional odor concentration of 1 odor unit per cubic meter. This is a piece of the standard. At that dilution factor, the odor concentration is 1 odor unit per cubic meter by definition. The odor concentration of the examined sample is then expressed as a multiple of 1 European odor unit per cubic meter at standard conditions for olfactometry. So the odor concentration is, as Laura said, the number of time the gas sample has to be diluted with neutral air, so that the diluted sample reaches the odor detection threshold. So there is, in fact, a linear relationship between the chemical concentration of the gas and the odor concentration. So when the odor gas is a simple mixture of N-butanol in nitrogen, the proportion is simple. So if I double the concentration, doubles also the odor concentration. For complex mixture, there is again a linear relationship, but in practice this is very more complex, because I can half the concentration diluted it, but I cannot double the concentration of a mixture in a practical way. This is totally different from what applies when dealing with odor intensity, because odor intensity is not proportional to the chemical analytical concentration. The standard provides the use of an instrument that is called olfactometer. You can see here two models that are in the market of olfactometers. There are many kinds of olfactometers, but the standard describe the minimum requirements, the important factor that has an effect on results. The olfactometer is not the measuring device. The measuring device, the sensor are and remain the panel members. But the standards provide both the requirement for the sensors and for the olfactometer, and contain requirements about the calibration of both the olfactometer and the panel member. These two are, as a whole, the measuring system. That is the combination of the olfactometer and sensors. That is the panelists, the assessors. Panel members are a small sample, a small sample of population, having a specific odor sensitivity to the reference odorant, that is N-butanol. In reality, the dispersion of this value on the population is much higher than from 20 to 80 ppb. This is a small sample of population. And there is no guarantee that this odor sensitivity is a mean, an average of the general population. This topic is too complex to be achieved, but the standard simply define a conventional odor threshold of N-butanol, but it is not necessarily the average odor threshold of N-butanol in a sample of population of South America or I don't know, China. Similar to other measuring methods by sensory analysis, the measurement and sensitivity of dynamic olfactometry is actually quite large, and larger than the uncertainty of the other typical measurement of air pollutants. But the standard define anyway, however, an acceptable window for the accuracy of measurement. Since the accepted dispersion of odor detection threshold to N-butanol among panel members within a factor 2 from 20 to 80 ppb, the overall measurement uncertainty has this same order of magnitude. So the published standard about olfactometry does not define exactly how to calculate the measurement uncertainty. The draft that as we elaborated now contain a new chapter about uncertainty, but the published standard no. But we can see that if the accepted dispersion of other threshold of a panel member can be within a factor 2, consequently the accuracy, the uncertainty of the overall measurement cannot be much narrower than this value. Obviously, if a single lab can guarantee better performances, it can declare the real accuracy, but all the labs that are in compliance with this criteria are in compliance with the standards. So it is possible to have this quite large window of acceptability of results. So for example, if the mean, the average concentration of between the panel member of a sample is 1,000 Odour unit, the confidence interval like this from 5,000 to 500 to 1,000 is reasonable, is possible, is acceptable. Dynamic olfactometry does not give any information about type description or origin, offensiveness, intensity of an odor. This is out of the scope of the standard. So a typical question from clients of a lab is, but how can I assign a sample to a source? There is no way by this method for attributes a sample to a source, because the results of the measurement method is the odor concentration and no other data. For example, a sample having an odor concentration of 100 Odour unit can have an odor intensity greater or lesser than a sample having an odor concentration of 200 of Odour unit. The first one can be more pleasant than the second one. There is no correlation between pleasantness and odor concentration and intensity with odor concentration. They are in some way correlated, but if I do not know the correlation, it is impossible to reach conclusions about this. In many cases, we see that the dynamic olfactometry is used to assess the odor concentration of ambient air sample or in general the concentration of ambient air. This is a quite questionable way of work, because first of all, the detection limit of the method is generally from 10 to 100. Laura said from,
very optimistic.
from 20 to 50. But assure odor concentration below 10 are not possible with the olfactometer on the market. But for a simple reason, in order to measure the odor concentration, I have to dilute it. So if the odor concentration of the sample is low, I cannot dilute it to measure the concentration. So for this reason, and also for the reason said before, the fact that the dynamic olfactometry does not give any information about the type, intensity, offensiveness, and so on, the determination of odor concentration in ambient air only in few cases give consistent and useful information about the odor situation in a generic outdoor site.
10 minuti.
The standards provides some information about the sampling, specifically the classical sources that can be sampled are point sources, active air sources, passive sources, and fugitive sources. The published standards does not go in depth about these topics. We are trying to do better in the next standard, but some many requirements, however, are contained in the standard about sampling. For example, as far as concerned the materials of the sampling equipment, or for example the way in which we have to avoid the contamination of the sample by the material in contact with the gas and so on. This is just a way to give some indication of the other concentration of typical emission that we can find in reality. You can see that other concentration spans over an enormous interval. So that is one of the reasons why the olfactometer has a logarithmic scale. So with one single instrument, I can in some way manage a such large interval of concentrations. A field inspection. A field inspection is not a new method, but it has been standardized at the European level just two years ago. There are two parts of the standard. This method is intended for determining the odor exposure, not the odor annoyance or the odor nuisance. But the odor exposure is in any way is an objective parameter. So if I am looking for a subjective description of an impact, I cannot pretend to write a standard. I don't know. Both methods are aimed to determine the extent of the impact rather than the magnitude of the impact nearby sensitive receptors. This is an extract of the standard. The part 1 is on read method. That is in practical. You define some positions on the around your source or your plant, your installation, and you repeat the measurement on a quite long period, like 6 months or 1 year, with a qualified panel. So they are trained panel with the same narrow window of other threshold as we saw previously for olfactometry, and you collect this data and you obtain a sort of map of the exposure in the field. So you are not interested in the magnitude, how the concentration is high in each single point, but how great, how big is the impact on the territory. This concept is useful because, for example, in Germany there is some criteria to decide about the acceptability. This is true, for example, in Germany, not in Italy. So if I perform a field inspection in Italy, I, for example, cannot decide about the acceptability, but it is another problem. Part 2 of the standard is quite simpler because we in this case I study the situation in a specific condition, under a specific wind speed, wind direction, and so on, and in a specific position, and also in a specific emission situation. On the contrary, if we come back to the other, the period of time has to be sufficient to be representative for the meteorological condition typically of the site in the part 1 of the method. So the two parts are different mainly from this point of view. As far as concerned part 2, the method is intended to determine the extent of recognizable odors from a specific source in a specific condition, and it is more simple, simpler than the other one. There are two sub-methods to do this. The first one is a stationary plume method, and the second one is a dynamic plume method. In the first one, the positions are fixed, and I use several assessors in the same time to do this, but the assessors are fixed in a position. On the contrary, in the other method, the assessor, one assessor crosses the plume, the position 2 is the source, the wind is from left to right, so what you see is a plume of the okay. And so there are two different methods, but quite equivalent as far as concerned the results. About the instrumental odor monitoring, there is a working group now open. We are trying to standardize this method. The working group is not trying to define a specific device or a specific technology or specific use of the technology. The aim is specify requirements for instrument other monitoring system, and the primary application is to generate other metrics that are relevant indicators for the presence and attributes of odor as would be perceived by human observers. So they are not chemical sensor used for, I don't know, methane. It is not relevant for us. What is important is to have results that are correlated with the human perception. If the correlation is not demonstrated, the results are not useful at all according to this standard. The core of the standard will probably be the clause about the validation of the odor metrics produced by instruments. The validation of the odor metrics is not the calibration. I don't know if I have I don't remember. Yeah, it is not a calibration of the scene of the scene the system. The validation of the instrument has to be done with a calibrated, trained instrument. There are two different concepts. The typical application for this technique, for this method, are ambient air, stationary emission, and also indoor air. The working group is trying to write a standard that can be used in all these cases. The kind of other indicators that are considered in the draft standard are presence and absence of odor, the odor quantity that is more or less correlated to odor concentration, it is a kind of odor magnitude, and it is considered as the odor concentration rather than the odor intensity. It should be linear, having a linear relationship to the chemical concentration, for example. And finally, the other class that is what source from what source the odor is coming, for example. The validation shall be performed in the field, so the validation in the lab will not considered sufficient to reach reliable results. Finally, just two words about other dispersion simulation. There is no any standard, any fully defined standard about other dispersion simulation, but as the main key factor of the technique are the quality of emission data and the quality of meteorological data. As far as concerned the first point, we have a standard about olfactometry. So we hope that the new standard can reach this result to have representative results for every kind of emission. As for concern, the second point is the quality of meteorological data. There is anyways some good practices available to have consistent meteorological data. So if from this point of view, the standardization of this method is not too far to be done. And I think I practice because the other dispersion results are generally presented in a map, as Laura said. The classical result presented in those maps are the percentile of hourly odor concentration and not the average odor concentration over the entire year, for example, because it is not useful information for our scope. Thank you very much.
Thank you, Andrea. Thank you very much, Andrea. Since we are very late, I will proceed with the next presentation by Carlos and keep the questions for the coffee break. So please, Carlos, will tell us something about other regulation and other impact criteria around the world.
How long do I have, Laura?
20 minutes. And please keep the time because we are already very, very late.
Yeah. Just tell me and I keep on the... Okay, I'm gonna change this.
Okay.